Somewhere in the universe, a bubble of destruction may have already formed, maybe billions of years ago, expanding at the speed of light, erasing reality itself as it spreads, and we wouldn't have a clue, even if it was just a minute away from reaching us. But before you start panicking, let's talk about the most probable way the universe will end. The universe has been expanding ever since the Big Bang, about 13.8 billion years ago, slowing down progressively, but roughly 5 billion years ago, the expansion started accelerating. We first realized this about 20 years ago, when scientists observed that distant supernovae weren't just moving away from us, they were accelerating. It was a shock, because gravity should be pulling everything back together, but instead something was pushing everything apart. This mysterious force is everywhere and makes up 68% of the universe, and it keeps growing. Scientists called it dark energy, and we still have no idea what it actually is. It's not a type of matter or energy we can directly observe. All we really know is that it's there. It's connected to the fabric of space itself, and it's making the universe grow faster than we ever imagined. At this rate, the universe doubled in diameter every 12 billion years or so. Galaxies drift farther and farther apart, eventually to the point where light will be too slow to make it anywhere. It will get trapped in the void, its roots stretching faster than it can travel. But on smaller scales, gravity still wins. In 4.5 billion years, our galaxy will collide with Andromeda, merging into a new supergalaxy, and so will other galaxy clusters across the universe. But beyond that, everything else drifts away, forever. In 100 trillion years, the energy in our supergalaxy would also run out. Everything in the universe will approach what scientists call heat death. All matter will be evenly spread out, and the temperature of the universe will approach absolute zero, about minus 273.15 degrees Celsius or 0 Kelvin. This is the point where no more work can be done, because there is nothing more to look at. The true end, where each single particle swims by itself in emptiness, never to see or interact with anything ever, forever. However, dark energy is still far away from predictable, and technically it might just get stronger over time. What if, in the distant future, dark energy becomes so powerful that it starts ripping apart the very fabric of the universe? Unlike the slow, cold death we talked about, the Big Rip is violent, relentless, arrives much sooner, and dark energy here completely overpowers gravity. It doesn't care how close galaxies are to each other, it will tear them apart no matter what. The expansion of the universe will accelerate to the point where gravity can't keep them bound anymore. In the next 2 billion years, star systems will begin to feel the effects. Planets will be torn from their orbits, and stars will be pulled apart. Even at this stage, gravity won't be enough to stop the force of expansion. Everything, no matter how close it is, will be separated. This will mark the beginning of the end for the very structures that make up the universe. Dark energy will go after the atoms. The building blocks of everything we know will begin to break down. Protons, neutrons, and electrons will be ripped apart by the immense expansion. The final moments will come when black holes, which had survived the earlier phases, start to lose their strength. These once massive objects, which can be billions of times heavier than our Sun, will eventually be stretched and torn apart. The black holes will grow so small that they'll finally explode, releasing a massive burst of energy. At this point, the expansion will have grown so extreme that space and time itself will lose all meaning. The fabric of space-time will be ripped apart, and there won't be a before or after. There will just be nothing. The universe will have been completely torn apart down to its most fundamental components, with no way for anything to exist, interact, or even be perceived. And once this happens, we can't even know what comes next. Everything we understand will break down completely. We can't predict what lies beyond that point because the very concepts we rely on cease to have meaning. If gravity wins the battle, the universe would still be doomed. The expansion of the universe would start to slow down. Eventually it would reverse, and the universe would begin collapsing back in on itself. About 50 billion years from now, the first signs of collapse would show up. Distant galaxies that had been pulled apart by dark energy would begin to move toward each other again. At first, gravity would only have a small effect, But over time, galaxies would begin to fall inward, merging with each other. As the universe contracts, stars, planets, and nebulae would be pulled into denser and denser regions. The radiation from all these collapsing systems would become intense, creating powerful quasars, the brightest, most energetic objects in the universe. These quasars would send out bursts of radiation so powerful that they would outshine entire galaxies, but even that would not last long. In this shrinking universe, black holes would become the ultimate survivors, growing ever larger as they suck in matter and energy around them. But these black holes won't remain untouched forever. As everything collapses, their event horizons, those points of no return, would grow, devouring everything in their path. Some might even merge into supermassive black holes, but eventually they too would fall into the ultimate fate. As time ticks on and galaxies merge, the heat and density would increase to such extreme levels that all matter would eventually collapse. Stars would burn out as their matter gets consumed by the gravity well of black holes, and soon there would be nothing left. Everything would become concentrated into a single point of infinite density, singularity, a state of infinite density and temperature. This scenario mirrors the conditions of the Big Bang, leading us to speculate about a cyclical universe, where each big crunch is followed by a new Big Bang, initiating a new cycle of expansion and contraction. However, we are theoretically always one moment away of the end. That's what I mentioned at the very beginning, right? Well, this is called a false vacuum state, a situation where the universe only seems stable but is actually teetering on the edge of something far worse. Right now, the fabric of reality might be resting in a temporary lower energy state, like a ball sitting in a shallow dip instead of rolling down to the true lowest point. If that's the case, then all it takes is one quantum event anywhere in the universe to kickstart a disaster. A single shift, and the universe could tunnel into a true vacuum, rewriting the very laws of physics in an instant. This catastrophe wouldn't spread like an explosion, it would be worse. A bubble of destruction would form and expand at the speed of light, devouring everything in its path. Galaxies, stars, black holes, even the fundamental forces of nature themselves would cease to exist inside it. No matter where in the universe it happens, it would eventually come for us and we'd never see it coming. Since nothing travels faster than light, by the time this bubble reached us, we wouldn't even have time to perceive it. One moment, the universe exists. The next, it's gone. And this isn't just some wild theory. The Higgs field, the same thing that gives particles mass, suggests that our universe might not be in its most stable state. If that's true, then vacuum decay isn't just possible, it's inevitable. It could happen tomorrow or in 1 trillion years. There's no way to know. But one thing is certain, if vacuum decay ever begins, it won't just change the universe, it will erase it. But these cosmic doomsday scenarios are way out of our control, and they're mostly far, far into the future. What's actually worth worrying about is surviving long enough to even see them happen, because we've come dangerously close to extinction, more times than you think, and that's exactly what we talked about in our last video. See you there.